Hey there, you're tuned to the Portable Crows channel. In today's video, we're going to continue our work on the FT-101. I don't have very many parts remaining. I do need to order some more parts. So with the parts that I have, the work that we'll do in this video is to replace some more electrolytic capacitors, some mylar capacitors, some dip mica capacitors in the driver circuit, as well as some resistors that we measured that were out of spec. So this will be a pretty short one. We're just going to do the work that we can do, and when I order some more parts, we'll do another video on those replacements. So stay tuned. We'll see if we can make this thing work a little bit better pre-alignment. So we'll see. All right, so we're looking at the very top side of our radio here, and the only electrolytic capacitors left, or mylar in this case, in here to replace are these two filter capacitors, which I don't have those parts yet, so I'm not going to replace those yet in this video. So everything else though on this side is done. So the rest of our work is on the back side, or the underside. So let's go take a look there. All right, so I removed all the covers on the bottom, and just to show you what capacitors I won't be replacing, there's this 2.2 microfarad capacitor right here. It's an electrolytic, and I don't have that component to replace. I don't have a new part, but in here it's labeled 2.2 microfarad at 500 volts. The part list says 450 volts, so this one's spec'd a little higher, but won't be doing that one today. Also, this 1000 microfarad rated at 25 volts, I do not have a new part yet for that, so I won't be doing this one. There's one down here in the rectifier. I don't have that one, so I'm not going to replace that. Not quite sure yet about this one. I have to look more into that one. So, so besides those two filter capacitors on the other side, which are right down there, that's all I have really left for electrolytic capacitors. So a few more parts to buy. But what we'll be doing today is this capacitor here, which is C116. The one right here, which is C63. This one here, which is C127. This one, C57. And this one, which is C54. So I'm just going to replace the few here, and after that we'll go switch and replace a few mylars. It looks like there's a mylar here and maybe right here, but that's just what I see real quick. I'll have to look at the part list and the schematic, see if there's any more. So quick work for today. I'll get a report back after I replace these. All right, real fast update. Looking at the part list, we're under the chassis list, and looking under the capacitors. Right here, C76, this MP 160 volt 2.2 microfarad capacitor, I believe is this one, 2.2 microfarad, 160 volts. NP, I'm not sure. I think that's like metal film. I don't know. I'll have to look into that one, but I do plan on replacing that when I order some more parts. So just wanted to update you on that one. All right, so I got all the electrolytic capacitors in that speaker area replaced. So I got the one down in here replaced. That one was pretty tricky. This one right here, this was probably the worst because the leads were wrapped, like twirled around the pin. I actually had to clip one and leave one in there. I could not get it out, and I didn't want to risk breaking the pin. And then we also got this one replaced, and the one right down here behind the microphone. So now what I'm going to do is looking at the part list, and this is for the chassis section under capacitors. We have, looks like just two mylars. So C49 and C18. I'm going to try to find those, and those will be the last two that will replace this for the mylar at least. And then yeah, and then all these electrolytics were done, other than what I pointed out earlier. This one right here, I got to order that. And if I adjust the camera here, 1 second, get that up there. So again, we need to do this one, and then there's one way down here by the transformer. And obviously the two big filter caps that are on the other side. Here's the bottom of them. But other than that, all the electrolytic capacitors are replaced. So getting closer to getting all those out of the way. So yeah, I'm going to go ahead and get the mylars. I'm pretty sure it's this one and this one, but I'm going to double check with the part list and the schematic just to confirm, and then we'll get those out of the way. Alright, so the orientation's a little different now. I rotated the radio, so now we're at the back side of the radio. This is the back side. We did change this mylar here, mylar capacitor that connects to the key input on the back, and then this mylar capacitor right in here. So those two that I pointed out earlier were indeed the two that we needed to replace. So I think what I'm going to do now is just get this plugged in and make sure everything still kind of works, no smoke, and then may move on to actually replacing those capacitors that we had in here. So let's just do a power on test and see what happens first. Alright, moment of truth. We'll see if this thing turns on. We just have the antenna hooked up to this manual antenna tuner, so I'm going to try to peak the noise, see if we can get a better signal. But let's see if this turns on and doesn't smoke. So 3, 2, 1. Okay, so I'm going to tune around and try to find a signal and see if this has improved at all. Alright, I couldn't get a good signal. I could hear some signals way down in the static of the noise, but nothing for a really good demo. Again, I think this thing needs alignment now from all the parts we replaced, as well as possibly the RF amplifier needing to be changed out. So I'm going to go ahead and turn this on again, and I'm going to turn the heaters on now. We'll let this warm up for a bit, and then I'm on upper sideband. The loading plate is at 3.5 roughly, like what the manual says for 20 meter. If I recall correctly, plate's like around 20, pre-select around 20. And all I'm gonna do is just make sure transmission works, and then I'm gonna put the carrier up and probably end up leaving it, or we'll start at 0 and make sure, see nothing happens, and then I'll probably just move it up to 4 and to see how much output we get on the meter here. And then for our next test, what I want to do is replace some of the capacitors that are recommended to replace, those dip mica ones, which we'll show you, as well as a resistor that's bad, one of those wire wound resistors. And then I want to do another transmission test just to see if we get more power just from those small changes. So I'm going to let this warm up for a little bit, and then we'll do our test. Oh, and my bad. We're using the key, so I'm actually going to be in CW mode, not upper sideband. So we've warmed these up for about a minute now. We are radios connected to this SWR watt meter, and then connected to this dummy load. So not using an antenna here. So I'm going to put this in Vox mode now, and then we'll key this with the carrier is set to 0. I saw it very, very slightly move. Okay, I'm going to go up to 4 now, and let's see what happens. Put out a couple watts. Okay, I'm going to go up to 5 and no higher. We're going to start at 5. All right, last one. Yeah, I would say about 2.5 watts there. So definitely need to work on our transmission. Again, I did not align anything, so keep that in mind. But I'm going to go replace those parts and just see if the needle goes up to maybe 5 and see what happens there. So let's go take a look at those. Let's turn this off. No smoke, so we're making progress. So I lifted up this trimmer board, and so in an earlier video we went over these capacitors. This capacitor here, C11, which is a 100 picofarad capacitor rated at 1000 volts. That's going to get replaced, as well as this neutralization capacitor, C13, the 200 picofarad capacitor rated at 1000 volts. Those are the dipped mica capacitors, so I'm going to replace those. And also, in that same earlier video, we went over these resistors, and I believe we confirmed that this 5.1K resistor was way out of spec, so we're going to replace that one. And I believe this one was within spec, but I'm going to take off one lead and remeasure it just in case. But I do have parts to replace both of these if we need to. So that's what I'll be working on now. And just here's a quick look at the new capacitor that will be going in. These are the new mica capacitors that I have. So here's the 100 picofarad version rated at 1000 volts. So a little bit smaller than what we have in there. Okay, so we got C11 replaced. That one wasn't too far out of spec. Those are supposed to be, it looks like, oh, they don't give us a tolerance on them on the part sheet. So, but it wasn't too far out of spec on that one. The neutralization capacitor, though, C13, that one was pretty far out of spec. It was measuring at 279 picofarad instead of 200. So the new one was 199 picofarad, and I'll show you a table here at the end. So we got our two capacitors replaced. I ended up taking the lead off of this pad here to measure this resistor while I was replacing this capacitor, and this is R37, this 18K resistor, and I measured it at 17.53K. So that one's fine. It's not out of spec, so I decided to keep it. But I did replace R5, this 5.1K 3-watt resistor. That one measured pretty far out of spec, so I'll show you that. So 2 new capacitors, new resistor. Definitely take some before pictures to make sure there's a lot of wiring on here, just to make sure you get them on the right spot. Also, this pad down here that you solder this neutralization capacitor to, as well as this 18K resistor to, was a really big pad with a ground strap on it, and I had to use my highest wattage, like a pretty high wattage soldering iron to get that hot enough to melt the solder. So keep that in mind. If you're replacing that, you'll want a high power soldering iron if it's similar setup with like a grounding strap attached to it, because yeah, it was very hard to heat up. So I'm gonna go ahead and button this all back up, put the cover and everything on, and then let's get to doing a quick transmission test. Alright, so we're going to do a similar test as before. We'll start with the clarifier down, 20 meter band. Everything up here has not been touched other than sorry, not the clarifier, the carrier. We're going to leave that at 0. Let's turn it on, see if anything happens. Okay, I'm going to let this warm up for a little bit. Okay, so I'm going to turn the heaters on now. And then I'll let it warm up for about a minute or two as well, and then we'll do our test. So while this is warming up, I do want to remind people, in case you're jumping into this video without seeing any of the earlier videos, I am new to this, so what I am doing may not be the right way. So just keep that in mind. I'm just here to have fun and experiment and hopefully get a radio working. So I'm learning along the way. So just keep that in mind. I'm a beginner here. One thing too, with the change in that neutralization capacitor, being that we're like basically 80 picofarads difference. If this was neutralized, this radio, if it was neutralized, I don't think it is anymore, just because of that capacitor change. So, we'll see what happens, I guess. And then I'm hoping we'll see a little bit more power now, being that fresh capacitors there and that one resistor way out of spec. So it's been a couple minutes now. Let's do our quick test. Again, carrier is at 0. So let's see what happens. Oh, we got to turn this in box because we're doing CW. So here we go. Okay. I'm going to go up to 4 like our last test. Let's see what happens here. Oh, I'm not getting any power out right now. Okay, I'm going to do one more at 5. Nothing. Okay. So now if we go to mux, instead of using the key, we're going to put an upper sideband. For an upper sideband, I'm just going to flip the mux switch up, and we'll see if that makes any difference. No? Okay, if we go to the power out switch, what happens? Nothing. So, we are not getting any transmission out now. So I did double check. All of our connections were connected. So, I mean, it wasn't putting out a whole lot of power to begin with, 2 to 2.5 watts. So maybe that's just enough difference with it, that one capacitor, the neutralization capacitor, being unneutralized even more now, potentially, that we don't get any power out. So I don't think our connections are bad. I will double check, but yeah, I hate to. I mean, we could try going up a little bit more. What do you think? Bad idea? Maybe? I'm going to go put it back in CW mode, and I got the carrier at 7. Let's just see if this moves at all. Oh, I got to put in box mode. I was like, I didn't hear the relay. Okay, it moved a little bit. If I put the watt meter, it's on 100 watts. I'm going to put it to 10 watt so we can get a better reading. Yeah, not even a half a watt. So I think we're just way out of tune now, which was expected. We're changing parts. So we do have a lot more parts to replace still. So I'm going to go ahead and turn this off, and then we'll talk about our plans here. Alright, just to give a quick recap of what we have left to do. We have these 2 capacitors. We have a few electrolytic capacitors underneath the radio that we need to replace. We have one dip mica capacitor inside the cage to replace, C125 I believe that was. And then capacitor wise we're done. So after the capacitors are replaced, I want to go and start replacing some carbon composition resistors that are bad. I know several of them that I've measured in circuit have been out of spec, so I want to get those take a lead off, measure it again, and if it's bad, replace it. So I am auto parts, so I need to place an order. I probably will do that in the next few days. So it'll probably be a couple weeks, I think, before the next video is out, because I gotta order parts and then start replacing stuff. So once all of the parts are replaced that I want to replace, then we're gonna have a video on aligning this, because as we just witnessed, with transmission is a lot worse off than it was just from those 2 capacitors and a resistor that we replaced. So definitely out of alignment now, as well as the receiver. The receiver seems a little bit weaker now after replacing particularly this board, the audio board. My guess is just thrown way out of alignment now. So Once we get those parts replaced, we get this aligned, then I think on this board here that has the RF amplifier, there's a MOSFET that people recommend replacing. I think I'm going to hold off on replacing that until after I get this aligned, just in case. These MOSFETs, they seem like they're getting harder to get, and I will order one so I have the part on hand, but I don't want to risk ruining the MOSFET that's on there now, replacing it, because on this early model, those are soldered in. So I can't just swap it out with the newer ones that have the plug, essentially, or socket, so you can put one in and out. So that's kind of the game plan going forward. Replace capacitors, replace resistors, align the transmitter and the receive side, and then if needed, replace the amplifier, the RF amplifier on that one board. And then hopefully that will all be everything that we need to do. Besides potentially, at that point, if transmission doesn't work, maybe we need new tubes. I'll have to keep my eye out on those. Seem to be pretty hard to get or very expensive. So probably won't be getting any of those anytime soon. Yeah, so that's the update of things to go forward in future videos. I do appreciate all the comments that come my way. I appreciate all the tips and tricks, any experience people can share. Just to reiterate, I am new to this, so anybody that's watching for the first time, I'm a beginner here, first radio restoration project for me. So learning a lot, but all the advice I can get, very appreciated. So anyway, I think I'm going to sign off from the Portable Crows channel for today, and I will catch you in the next video here, hopefully in a couple weeks. So 73.
I'm now a radio man. You can bet your boots he knows his stuff.